All right, welcome everybody to week 11, day 1, lecture 2. First lecture was on debugging today. Second lecture is on classes. I'm splitting them into different recordings so you don't have to skip around inside of the same one. So classes are a pretty important concept. In fact, it's really the last major concept in this class. We're on week 11. It's time. So, especially since your Zybooks requires you to know classes before you can learn pointers for some reason. So there you go. So the Zybooks on pointers has been kicked back 2 weeks. Your next Zybooks is going to be due in 1 week, which is on this. So you don't have to worry about pointers for now. You're going to have a little bit of a respite on it. Okay, so today we're going to be talking about classes. A brief introduction to classes, a gentle introduction to classes. In CSI 41, you're going to get sort of the full lecture. You're going to learn the proper way of doing class design and things like that. For this lecture today, you're going to be getting sort of the easy version of it. Okay, so let's get going. All of the types that we've been working with so far are either built into the language itself, like an integer or a char or a double or a float, or they're part of the standard library, like string and vector. Okay, and it would be cool though, like if you could make your own class, right? Like if you could have a class specifically for the needs of your assignment, the needs of your program, whatever it is you're working on. And you can make it by using something called classes and structs. Structs and classes are more or less the same thing with a minor difference we'll cover. So let's say that we want to make a data type that held complex numbers. And in fact, there is something that does this in the standard library. Well, let's say that we wanted to make our own for whatever stupid reason. So complex numbers have a real part and an imaginary part. Right? You guys remember complex numbers from like Algebra 2 or something like that? You got a 3 plus 7i, 5 minus 6i, that kind of stuff. You guys remember complex numbers? You know how to add them together? So if you were to add these two complex numbers together, what do you got? No. You don't like imaginary numbers? It sounds like my daughter. I was telling Lewis in class today. First time I told my daughter about negative numbers, she was philosophically opposed to it. She's like, "You can't have negative apples in your hand. It doesn't make sense." You know. And then I told her about imaginary numbers, and she rejected. Ada, what do you think of imaginary numbers? What do you think of imaginary numbers? Double thumbs downs. Perfect. That's perfect. Great timing. Okay. So, what happens if you add these two complex numbers together? Do you guys know? Do you remember how to do this? Anyone? You add the real parts together. You add the imaginary parts together. It is indeed 8 plus 1i. Yes. Or 8 plus I guess. Okay, so you can do that right now with what you know, right? You can make a couple variables. You know, you can make a real one, imaginary one, real two, imaginary number two. And then you can add like the real parts together, and then you can do this thing called show POS. POS stands for what? And then you add the imaginary parts together, then the I, then the end line. Does anyone know what POS stands for? Position? Nope. Piece of sign? Nope. Yes. Lewis has it correct. POS means show the positive sign. So normally, if you were to see out 10 to the screen, it just prints 10. But if you do a show pause, then it will print plus 10 to the screen. Normally, the plus is omitted. The negative's always rendered, right? It'll always, like if it's negative 10, it'll always do negative 10. It doesn't matter whether you have show pause yes or no. It doesn't matter. It's always negative 10. But if you have positive 10, normally it just prints 10. But if it's positive 10 and you have show pause turned on like this, then it will print plus 10. And we need that to get the complex numbers looking like this. You want the little plus here in between. Okay. So it'll add the real parts together. It'll show the positive if it's positive. We add the imaginary parts together. Tag a little I on the end, inline, and we're good. Okay. So it's okay. This is okay, right? It's all right. But it gets kind of weird, like especially if you're trying to make like a vector of these complex numbers. And so you've got like you've got like an array of like the real numbers. You've got like an array of like the imaginary numbers. They like go with them, and like you have to really hope that like you don't delete one from one and not from the other, because then everything gets screwed up. And it's really just sort of awkward to deal with, right? Like you got to go into a real array 50 and into imaginary array 50 and grab the two parts together to add them, and it's just kind of janky and weird, right? And so what we do instead is we make a class that contains a real part and an imaginary part. And so this is what it's going to look like in main after we've made it. I'll show you how to make it next, but I want to motivate you. I want to justify why we do this. Like, rather than doing this kind of nonsense here, which it'll work, and you can do it, you can do this instead, right? So you can say make two complex numbers, one named first, one named second. The real part of first is 3. The imaginary part is 7, right? And then we've got 5 and negative 6, right? The real part is 5. The imaginary part is negative 6. And then we can add the real parts together and the imaginary parts together. And so you can see, you pay attention here, we got this little dot operator here. This is the learning point for today, the dot operator. Every variable that's a complex number, it's really two variables in one, right? It's the real part and it's the imaginary part. And you can access the sub-variables by using the dot operator. So everybody, what is first dot real? What number is first dot real, do you think? 3, yeah. So by doing it this way, this is called universal initialization syntax. Universal initialization syntax, braced initialization syntax, list initialization. There's different ways of naming it. What this does is the first value here gets put into the first thing in the type, which is real, and the second number here gets put into first dot imaginary. Yes, you are correct. So this is 3. And then what is second dot real? What is second dot real? What number is that? Good. That is 5. Okay. So we're not talking about first dot imaginary at all. We're talking about second dot real. So second dot real is 5. And then show the plus sign again if it's positive. And then we're going to add the imaginary parts together. So first dot imaginary is 7. Second dot imaginary is negative 6. 7 plus negative 6 is 1. So it's going to print out 8 plus 1i. And later on in CSI 41, you're going to learn how to do this. You can actually make it so that you can just add two complex numbers together, and they'll add. And it doesn't know how to do this by default, right? Like C++ has no idea how to like add complex numbers, or even worse, multiply complex numbers using FOIL, first, outside, inside, last, or even worse, using complex division, which involves like multiplying by the complex conjugate. C++ has the compiler has no idea how to do any of that. You have to teach it. So in CSI 41, you're going to learn how to teach C++ what happens if you add two complex numbers together. What happens if you multiply two complex numbers together? You have to write that function. And that's an assignment for next semester. I think Curly wants to give it to you guys now. And I don't know, maybe I could be talked into it if you guys are like pretty excited about it. But I'm cool for now. So yeah, so we can actually do this. Like, we can actually make a class that defines a new type called complex and has two parts to it, real and imaginary, and it looks like this. Okay, so so we'll go over the syntax, but let's just take a look at this. Basically, what we're saying here is this type called complex with a capital C has two member variables in it, two sub variables in it. One called real, one called imaginary, and they're both floats. Okay. So that's what this is doing. This isn't making a variable. This is defining a new type. We're saying there is a brand new type that we can make variables out of, and each one of these variables is really just two floats living together under one roof. They're roommates, right? So when we make this variable here named first down in main, it's of type complex, and so it has a dot real and a dot imaginary. And dot real comes first, so 5.1 goes into real, negative 3 goes into imaginary. You then set first dot real to 12. And so when we see out first dot real, what is this going to print here? So do you guys see how the dot operator works? Like it accesses the sub variables within a class. So what number is this going to print to the screen here when we print out first dot real? Is it going to print out the 5.1 that it originally was, or is it going to print out the 12 that it has been set to afterwards. That is correct. It will print out 12. Good. It'll then print the plus sign if it's positive. It's not. It's not. So it's not. This doesn't do anything actually in this case because it's a negative number. But then it's going to print out first dot imaginary. What is first dot imaginary? Delete this note here. We don't need you. A little complicated for now. -3 is correct. So this is going to print out 12 minus 3i. Okay. The syntax. Let's go through the syntax now. Okay. So in order to make a new class, a new type, you say class, or you can use struct, and we'll talk about structs later. You give the name of the type, and then you got curly braces. And there's something really weird about this whole thing, which is that there is a semicolon after a curly brace. And this is kind of weird. The only other place I can think of in C++ that does this is a do-while loop, and I kind of hate do-while loops for the same reason, because they put a semicolon after a curly brace. So, yeah. Everybody forgets it's semicolon. If you've done Java or C# programming before, you've probably never seen a semicolon there before. And if you forget it, it will tell you forgot it, because everyone forgets it at one time or another. Remember what I said? Experienced programmers make just as many dumb mistakes, maybe a little less dumb mistakes than new programmers. But once we forget something, we're like, oh yeah, and then we fix it and we move on with our life, right? So if I were to come over to the server, I closed out of the server, didn't I? Okay. If I come over to the server and I make a point class here. And I forget the semicolon there, it will give me, oh, error. It says expected a semicolon after a class, right? This is a extremely common mistake that people make. Error, expected a semicolon after a class definition. Very common. It'll point right to line 10, right there. You forgot a semicolon, right there. Right there. That's where you fix it. Like it tells you, you know. So line 10. If you remember how to get to line 10, type in 10, Shift G. That'll take you there. Or you can vim main.cc line 10 like that. That'll take you there. It's like right there. You need a semicolon. Okay. So this class here is for like a point on a 2D coordinate system. This is a very common class that people make. And so class is the keyword, meaning we're making a new type. Point is the name of the type. Then we've got a open curly brace with a closed curly brace and a semicolon. Don't forget the semicolon. Don't forget the semicolon. And then inside of it is the definition of the class. And so what we're saying here is that every variable of type point is going to have two public variables named x and y. What does public mean? Don't worry about it for now. Just make everything public for this class. In CSI 41, I will teach you proper class design, the right way of doing things. For this class, just make everything public. It's not a big deal. It's really not. It'll be fine for CSI 40. In 41, we'll get into like proper object-oriented techniques and things like that. But if you really want to know what private does, private, if we make a variable named z, and you can have the variables initialize themselves. Yeah, that's cool. So if you were to like cout min corelli.x, comma min corelli.y, what is this going to print to the screen? What is this line going to print to the screen? What do you guys think? Good job, Bencourt. It is, in fact, 0, 0, right? Because when you make these, we got two variables of type point, min corelli Brereton, and the x is going to initialize itself to 0, and y is going to initialize itself to 0. If you don't have these in here, then it's anyone's bet what's going to happen. Like, I don't know what's going to print. It's undefined behavior. Warning, it's used uninitialized. I know. And so we got a 0, I guess. Doesn't have to be. We're getting zeros. Doesn't have to be. This is uninitialized data, right? So always initialize your variables. And then here we got a z that is a private member variable. So a private member variable means that everything in the class can access it, but nobody outside of the class can access it. So if I tried, for example, to cout min_corelli.z, you will see I get a compiler error. And the compiler is saying, I can't access that. I do not have permission to get access to z. The only people that can access z is lines of code within the class itself. Okay. So why not use structs since everything is public? You certainly can. I'm about to get to structs. So the Zybooks do talk about privacy and things like that. For this class, for your homework assignments, like I said, just make everything public. It's fine. It's simple. It's easy. It's teaching you bad habits. That's fine. We'll correct all those bad habits in 41 if you make it that far. Hey, what's going on, Hazelton? So, if you want to make everything public, that's cool. Okay. Now, main can access z. All right. Now, if everything's public, yeah, you can do something called a struct. And a struct is exactly the same thing as a class, except it defaults to public. That's it. That's the only difference. If you make a class and you don't have anything on here, it defaults to private. And none of these things work. Look, this is private. This is private. Everything's private. It's not useful. So for a class, you just have to slap a public on there. If you want to save a little bit of typing, you can make everything public by doing a struct. And that's probably how I would do it if I had to do your homework assignments in this class. Make a struct, make everything public. It's fine. We will teach you good habits next semester. For now, don't worry about it. Okay. So there's one other thing that needs to be mentioned with classes. And remember, classes and structs are identical. It's just the default public versus default private. That's it. There's one other thing you can do with classes, structs, and that's add functions to them. So for example, if I were to add a function called int distance, let's make it a float even. Let's make all these things floats. Float distance from origin. Takes no parameters, and it returns, this returns my x times x plus y times y square rooted. This is the Pythagorean theorem, right? And so if we represent like a point on a two-dimensional grid, this function here, distance from origin, is going to return how far away the point is from 0, 0. Okay. So if we were to set, for example, if we were to set min Corelli.x equal to 3 and Corelli.y equal to 4, and we were to cout min Corelli dot, watch this, dot is not just used for variables, it can also be used for functions. Dot distance from origin. Does this look familiar, by the way? Before I ask you what this is going to print, have you used any member functions before in this class? Have you ever done a dot and then a function on something? The only classes you've worked with so far are strings and vectors. So ints don't have this, doubles don't have this, chars don't have that. Those are all primitive types. But what dot member functions have you used in this class so far? Yeah, dot size, good. Dot at, dot pushback, good. Yeah, so those are all functions that are written on a class. So vectors are a class, strings are a class. They're not primitives. Even though they come with a language, they're part of the standard library. They're not actually part of the language itself. If you don't hashtag include the right things, like vector, you can't use a vector. They're not baked into the language. Okay. So we made ourselves a member function. And what this is going to do, it's going to take our x and our y, square them, add them together, return the square root. That's the Pythagorean theorem. So it's going to return how far we are from 0, 0. So if Min-Corelli is at 3 east and 4 north, how far is Min-Corelli from 0, 0? Does anyone remember their geometry lessons from a while ago? Trigonometrical truths. What is 3 squared plus 4 squared square rooted? Over 9,000? Yeah, it'll be 5, hopefully. And there we go. Yeah, so we got 5 is the answer. Okay. So we can do the same thing for Brereton. So Brereton he's going to be 10 units east, and he's going to be 10 units north. And so if we see out and if you guys want to know how I did that, I typed 10s Brereton, and then I use dot to repeat the command. For the people that say, oh, them doesn't save you any time. Yeah. All right. So 10, substitute 10 characters with Brereton. Then I can just use dot. And if I really want to be fast, I could like / Min-Corelli and just be like dot. Oops, sorry, not after I've typed it again. 10s Brereton next dot, next dot, next dot, next dot, next dot, and I can just blow through the whole thing like that. Okay, so what is this going to? Yeah, DW is fine, but like then you can't use dot because it's 2 commands. DW is 1 command, and then insert Brereton is another command. So you can't use dot to like do it. You'd have to make a macro, and yeah, it's extra steps. Change word, yeah, that'll work too, for sure. Okay, so what is this going to print? Anyone remember their trig? So you do change word, and then repeat using dot as well. Square root of 200. Okay. What is the square root of 200? Anyone remember trig? 20? If we're doing Manhattan distance, so Manhattan distance is something you'll see in computer science a lot. It's like when you travel in Manhattan, you can't travel on diagonals, so you have to travel east and north, right? So the total amount of distance traveled, if you have to go 10 blocks east and 10 blocks north, is 20, because you traveled 10 east, 10 north. There's no diagonal shortcuts you can take using Manhattan distance. So under Manhattan distance, yeah, it'd be 20. But we're doing Pythagoras. So weight 10 root 2. 2 root 10, square root of 200. Trig, people? What's the root of 2? Square root of 2. 14-ish. You guys remember square root of 2? 14.14. Okay, so basically done. One thing that you will see in the Xi books that is more of a 41 topic is they don't like this approach. They try to teach you the proper method from the beginning. So they have a public section and they have a private section. So the public section is what you might call the interface. Those are things that could be called from main. And the private section will actually have your data in it. And so what they do is they create these things called getters and setters. And so they'll have a function that like it's called get x, and it will return x. Don't worry about the const for now. Get y. You don't need it technically. It'll work without it, but just, I'm putting it there because I don't want to teach you bad habits. Return y, and so that'll return the values of x and y. And then if you want to set the values of x and y, you need a set x function. It takes in new x and sets x equal to new x. And then we will have a get x. No, set y, sorry. Set y, the new y, and y equals new y. And there we go. So now you can see that we can't set x and y directly because they're now private. Nobody can access the private member variables of the class except for the class itself. So this is fine here. You can access x here, you can access x here because you're within the boundaries of the class. So these things, because they're marked in the private section, can only be touched between the curly brace here and the curly brace here. So this is not allowed. So what you have to do instead, if you want to set the x, you have to change this to mincrelly dot set x3 and mincrelly dot set y 4, and then instead of dot x, you have to call dot get x, and that's a function now instead of a variable. And mincrelly dot get y, that's a function also. This one is still a function, and then these guys, I'm not going to redo them because it's too much typing. So you can see we're basically doing the exact same thing here, except instead of setting x directly by saying x equals 3, we're making a function called setx that takes 3, and then it sets x equal to 3. And so it adds a layer of indirection between the variables and main. Personally, I wouldn't write it this way. I would actually do it the previous way with the struct. And the reason being is because when you have something simple like this, where it's just a couple variables hanging out together, yeah, I probably wouldn't go to the effort of writing getters and setters and just making everybody annoyed at me. It's like just extra typing for no reason. So one thing we forgot to do is constructors. Yeah, we'll talk about constructors on Wednesday. So yeah, this code here is exactly the same as the code before, just with more typing. And yeah, we got a private section, we got a public section. Yeah, so that's basically the first lecture you'll have on classes. You guys have any questions for me? Dot is how you access the member variables. These things here are called member variables. These things up here are called member functions, aka methods. Everything in the object-oriented world, which is what we're learning here, has like different names for everything. It's kind of annoying. They're not variables, they're objects. You don't make a variable, you instantiate an object. You know, they're not functions, they're methods. Whatever. You guys have any questions? Is this a scale of 1 to 10 on difficulty? How complicated is this? Medium difficulty. Okay. Well, we will work more on it on Wednesday and talk about constructors then. And we'll give you some lab time where you can like make your own class and get some experience doing it. Okay, we've got medium difficulty votes coming in here. So this adds a little, like anytime you add indirection, like it confuses students. You know what I mean? It's like, I want to just be able to set x, man. I just want x to be equal to 3. You can't. You have to go through like the front door, you know. You can't just like get x. You have to like call get x, you know. And so, do you guys concur that like doing it like this is like a little bit easier? I deleted too much. Oh, do you guys understand this? How hard is this to understand? Pose the same question. 1 to 10. Difficulty of understanding this. We've got a variable here of type point. Every time you make a variable of type point, it's really 2 variables. It's a dot x and a dot y. They kind of come together. And so if you ever make a vector of them, then like the x and the y come together. You don't have to have like separate arrays for like the x's and the y's and things like that. Difficulty 1 to 3. Yeah. Constant of e. That's funny. Yeah, I think, and that's usually why I teach structs in CSI 40. So you're going to get a lot of experience doing programming with structs. Zybooks kind of teaches you the proper way of doing things, but for me, that's more of a 41 topic. So I get you comfortable with all this stuff, and then we like kind of like do that other thing that I showed you with like the getters and setters and things like that next semester. Okay. So for my stuff, you don't have to do it the proper way yet. You guys with me? You guys cool with it? This isn't too bad, I don't think. All right. Cool. So make sure you get Bridges Mountains done by Wednesday. And make sure you start working on those debugging things, and really try to think about like deliberately like building your skill with debugging. Like it's like you got an XP bar, like in a video game. Like you build up experience, right? And so one of the things you can build experience with is debugging. One of them is like writing code. Another one's like knowledge of C++ or whatever. You know, there's a lot of these different XP bars that you like build up and you like level up in them and you get better at them. And so debugging is something that it's a skill that a lot of people neglect. Reading code, like reading other people's code, like the Bridges people, like reading their code, that's a skill you need to level up in, and being able to look at their code and understand it and find where bugs there are and try and figure out what they're doing, things like that. All that stuff requires skill and practice and stuff like that. So that's it for today. I will see you guys on Wednesday. Peace.